Okay, so it says, given this chemical equation, if the initial concentration while the reactions is 2 moles per liter, answer the following questions. What is the Kc expression? And fill in the ice table for this reaction. What are the concentration of each of the gases at equilibrium? Okay, so first let's write down the chemical equation. We have carbon dioxide reacting with H2O gas. To form, we started off with carbon monoxide to form CO2 gas plus hydrogen gas. Okay, so first let's make sure that the reaction is balanced. We have 1 carbon on each side, 2 oxygens, and 2 hydrogens, so everything is already balanced. And now we can just construct our ice table. So since none of these compounds are solids or gases, they will all be included in the ice table. So they gave us the initial concentration of all the reactants, which is 2 moles per liter. So both water and carbon monoxide will put 2.00 under its initial concentration. And the initial concentration of our products, obviously we both just have 0. Okay, so moving on to the change for both the reactants, it changes by -x, and for our products, it changes by +x. And we know this because as a reaction progresses, we start to lose our concentration of reactants, and we start to gain more concentration of the products. And now we write the equilibrium expression, which would just be 2 minus x. And then our products will just be equal to x. Okay, so now I'll write down the expression of Kc, which is our equilibrium constant, concentration constant. So this is found by multiplying the concentration of our products. So our products are CO2 and H2, and it's going to be divided by the concentration of our reactants, which is carbon monoxide and water. So the question gave us the Kc value, which is 3.80. And instead of writing the concentrations, I'm going to write the expressions we found for all of them from the previous ice table. So if we have the concentration of CO2 and H2 both equal x, when you multiply it together, you get x squared. And then for the denominator, it's going to be 2 minus x times 2 minus x. Okay, so now we get this quadratic kind of like expression. Let's try to simplify it and try to solve for x. So the goal is just to write this as a quadratic equation so that we can plug it in to the quadratic formula and solve for x. Okay, so this is just using some high school math. First, outside, inside, last gives us 4 minus 4x plus x squared. And then simplifying this some more, let me bring this up here. You should end up with 2.8 x squared minus 15.2x plus 15.2 is equal to 0. And now just by using the quadratic equation, or you can use like a quadratic equation calculator if you looked it up. We want to get the x, like typically we want to get an x value that is the positive number. But you'll notice that when you find the value, the two values of x that you would get if you solved this equation, you'll notice that both of them are positive. So the x value that you want is going to be less than 2. And we know this because if it was greater than 2, then we would get a negative concentration when plugging it into 2 minus x for our reactants. So if we take the value that is less than 2, you should get x equal to 1.32. Okay, so now that we know what our x value is, we can now write down the concentration of each of the gases at equilibrium. So part C, at equilibrium, the concentration of carbon monoxide is equal to the concentration of H2O, which is equal to 2.00 minus 1.32. And you get 0.68 moles per liter. And then lastly, the concentration of CO2 is equal to the concentration of H2, which is just equal to x. So it's 1.32 moles per liter. Okay, so let's see what the junior tutor wrote. The reaction above is an example of a reversible reaction. At the end of the reaction will reach a state of equilibrium where the rate of the forward and reverse reactions are equal and the concentration of the reactants and products remain constant. Moreover, since the reaction happens in one phase, a homogeneous equilibrium will occur. Part A, writing the Kc expression, we just need to plug the species into an equilibrium expression. Remember that the numerator is for the products and the denominator is for the reactants. Thus, Kc is equal to CO2 times H2 divided by CO times H2O. B, for the ice table, we need to remember that the concentration of the reactants decreases in the same rate that the concentration of the products increases. This is so because the coefficients of the species are 1. We will denote that amount as x. Okay, so this is what their ice table looked like. And then to calculate for the equilibrium concentrations, we substitute the expressions in row E of the ice table to the Kc expression. Okay, so they showed their work with the quadratic formula. And here they had the x equals b, well, negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so you can see here that they got the two different x values. So one of them was greater than 2, and one of them was less than 2. So they said we will choose the second root since we are to substitute the value of x to the expressions in row E of the ICE table. Using 4.1 would result in a negative concentration which is not allowed. Using the 1.32 as the value of x, we get 0.67 molar as the concentration of carbon monoxide and water, and 1.32 molar as the concentration of CO2 and H2 at equilibrium. Yep, so this solution is correct. Okay, so now let's move on to question number 6.